Okay, let's go ahead and get started. Again, my name is Van Miller, and I've just started with EPLAN just a couple of months ago, but I have been involved with control panel manufacturing and working with panel builders in terms of shop floor automation and connectivity to the engineering process. So I was with Rital about 5 years previous to coming on board with EPLAN, and my pleasure to have you all here with me today. So let's go ahead and get started. So by this point, I'm sure you've run across our infinity loop here, which is a representation of the customer's value chain and where we bring solutions to help our customers improve their processes. So today, we really want to be focusing on the manufacturing floor, and we'll step through some of the items shown here. We're going to concentrate on some of the processes which really benefit from automation and create the largest impact to your manufacturing space. So before we get started with that, just wanted to throw out this slide, which is talking about the concerns that most panel builders that I interact with have when they're coming to talk to EPLAN and RAS about their shop and how they're working today. And we see the biggest pressure coming from increasing prices, shortage of skilled labor. I mean, certainly before the COVID-19 pandemic, this was a very large topic with a lot of customers over the last couple of years, not being able to find good resources for panel builders out on the floor as well as engineers up front. But then also, there's that all everlasting pressure to reduce delivery times to the end customers. And, many customers recognize that there are inefficient workflows and quality issues on the floor and are looking for ways to address those. So, just wanted to take a look at what I see as the kind of current state of a lot of panel manufacturers throughout the United States. I believe over the last 13, 14 years, I have probably been inside of close to 500 panel shops, both here and abroad. And these are all common attributes that I see. So a lot of customers are working on an engineering to order basis, meaning that they're taking existing engineering documentation and then manually modifying it. So they'll find a project that looks very similar to what they're going to be building, and they start from there. But the problem is often this will actually carry forward embedded errors. Also, it's long quoting cycles involved with this type of engineering. Often the engineering department has a decent backlog and has a lot of pressure on it. So this is a continual pressure. Documentation revision management is, constantly a theme. Just making sure that all of the associated documents and data are revised when like an older project is brought up and revised for a new job. Also on the order to remittance side, so managing data between the design group, purchasing folks, and the manufacturing people is, it's time intensive, making sure that all of the correct, documentation is on the floor at the correct revision level. And once the project goes out to the customer, just ensuring that the as-built documentation is also correct. And then, a couple of years down the line, perhaps the customer is calling for replacement components or assistance with a unit that's down. That aftermarket support is incredibly important. So, we are looking at that as, kind of challenges that our customers face today. Then out on the production floor, just a couple of examples of where we see the biggest buckets in terms of time consumption, where, the panel build is really taking a lot of time. One being the enclosure and back panel modification. So talking about the layout of all the components on the back panel or on the enclosure, marking out all the hole locations and hardware requirements, center punching, and this is once all the components have been taken back off the panel, center punching, drilling, tapping, all of those holes, and then the cutouts. Certainly in the enclosure body itself, often for filters, fans, HMIs, that type of thing. Those areas need to be marked and taped off before they're machined. Wire processing, certainly the largest bucket out there typically. We see somewhere between 50–60% of the time a panel spends on the floor in wire processing. So schematic reading and marking, so this is often how people are working through and wiring the panel. So it's a slower process. So hand cutting the wire off of spools, stripping wire, crimping, labeling, and then finally, landing that conductor in the control panel. So all of these tasks are currently very manual in most panel shops throughout the country. What we are going to be showing you today is how we can really leverage the information, the data coming out of EPLAN software in a virtual environment and drive that information directly out onto the panel shop so that we have a one-for-one instruction on how that panel should be built. And so looking at the automation in the engineering department itself, I mean, by this point, you've probably seen some demonstrations on EPLAN's capability and a lot of the automation that it brings to the mundane daily tasks that engineers encounter. So, but of course, the data quality is very highly maintained between all documents and reports. Lower overall engineering costs through this type of automation, just getting the design done faster, and as I said, eliminating a lot of those mundane tasks. So, and of course, once the project is complete, we can send that data out to the manufacturing floor, which will assist with visualization of like the 3D engineering, being able to make sure that we don't have interferences and making sure that the panel is laid out correctly before going out to the floor. Wire routing and data for advanced wire processing systems, we'll be looking at that, as well as the data required for CNC machines for modifying enclosures and back panels. And outside of those, those steps we can also help automate and streamline DIN rail and wire track kitting, automated terminal block assembly should your company use a lot of terminal blocks in the production, all the required label printing and kitting requirements for the panels, and then just showing a method of paperless panel wiring. So really trying to get the paper off the floor and work in a more digital environment. And I just wanted to mention a couple of overall benefits, in my view, to database-driven engineering. So this is really, an architecture for an engineering platform in EPLAN, which is different than most customers are working with today. And that is that, we've got a component article database foundation underneath the software, which allows us to drive a lot of design variations once we have those components in our database. Components can be used together with intelligent schematic macros, which then can be saved and reused and drive further efficiency, so that we're creating large chunks of circuitry inside of the panel design and can save those and reuse them. One really important piece here, I think, is that all the component information is stored in one place, which avoids maintaining data in several different places in the company, formats and locations. In some cases, you'll see a project at a panel shop where the schematics maybe are done in CAD, but the bill of materials is over here in Excel, and then we've got maybe a Word document that talks about the P&ID, etc. So you get the idea that there can be several different pieces of information that all belong to the same project. Just to state here that each component is also carrying with all the critical data that we need for subsequent manufacturing automation. So the technologies we're going to be talking about, and we can carry, of course, with that component 2D, 3D dimensions, electrical functions and properties, mounting requirements for mounting that that component on the panel, as well as wire and connection points, which we will see is very important. Just a quick note here. I think everybody recognizes this, but I think it's worth mentioning that the cost of errors. Certainly, the earlier on we catch errors, preferably in the engineering department, the better, because they're less expensive at that point. Of course, the further down the manufacturing process the panel goes, the more expensive that gets. You get into testing that can be very detrimental. But certainly think about a panel being out at a customer site with a problem. Of course that increases the cost several. So so the technology that we really are going to be concentrating on today are going to be the piece of equipment that we see here, and showing how the EPLAN platform can drive data directly out to these machines. So having the advantages of eliminating human input errors, really just changes are being done in one system only. So it's not difficult to keep track of revisions and say engineering change orders out on the floor. So data for automation of processing enclosures, back panels, wire ducts, DIN rails, wire conductors, and terminal block assemblies. I mean, even right down to the printed labels for device IDs and things like that. So the first piece I wanted to address today was, at the beginning of the process, which is enclosure and mounting panel modification. So as Rittal Automation Systems and EPLAN, we're showing you today the Perforax machining centers. So we have two different options here, depending on the production mix that the customer has. The first unit is the RAS BC. This is essentially a piece of equipment specifically designed for panel builders to modify enclosures and back panels, and it employs a mechanical end mill to do the cutouts of things like filters and fans. So both of these machines can drill, tap, and cut out larger openings in the material, and we can work on any surface of an enclosure, say a 3D welded block box. Both machines are fully capable of that. Essentially, we can work in all sorts of materials, whether it's steel, stainless steel, aluminum, plastic, Lexan, fiberglass, copper bus bar, etc. So most of the materials that you encounter as a panel builder. And both machines offer roughly 85% of total labor cost savings. So we're dropping 85% of the time out of what customers typically require for panel layout and machining. Like any automated process, we can expect improved quality with no rework of those enclosures that you're buying that are expensive. And also we offer the opportunity of reducing potential inventory of pre-customized enclosures or long lead times that may incur from panel manufacturers, or I should say enclosure manufacturers, to you. So really being able to take stock enclosures directly off the shelf and modify them directly for your job's needs. And really important point here, going back to the shortage of labor, is being able to use existing labor resources on the floor for much more value-added activities such as panel wiring and testing. So, so I was just going to at this point, pop up a couple of videos, just to give you some visual idea of the Perforax machine. So hopefully you can see that okay. So this is the Perforax BC unit. So this is the mechanical end mill machine. And let's see. The Perforax is vertically constructed. So we were actually putting work pieces on vertically instead of horizontally, like you see like a lot of CNC machines out in the world. All of the clamping and standoffs for the workpiece are specifically designed to not scratch and mar the surface, whether it's painted steel or carbon, stainless steel, etc. So very simple operation. And what we'll see here is the machine is picking up 1 out of 20 tools on the left-hand side out of the magazine and processing the panel according to the data. And, we are seeing a drilling process here. We'll also see a bit of tapping, and then later on some of the mechanical end milling with this machine. We do, check all the tools before we put them away, and we incorporate some other technologies with the machine, such as a pressure plate system, which you'll see in a second, which is actually stabilizing the material here, with these all-directional red wheels, and while it's doing the cutout. And just a note, what looks to be burrs there are actually just the paint of the enclosure, so they're easily removed. She's removing basically a large piece of metal right now. We just wanted to get rid of that by hand and not have it free fall. But the machine will come back and clean up those retention tabs that had kept that piece of metal in place. And as you see here, she's just removing the paint from the cut. So, so not only can we work on a flat part across the entire surface of the machine, but as we'll see in a second, we can also load a three-dimensional cubicle, and that's done by opening this door here and just loading, say, like a wall mount box, like Ellie will be grabbing in a second. And so the 0 points on the machine are hard mechanical 0 points, and we see the motorized depth and control bringing the workpiece up to the 0 point in the Z-axis. Here, all of the clamping systems are very simple and easy to use. So we use Festo pneumatics to really grab onto that workpiece and hold it stable during the machining process. So I think, that gives you a pretty good overview of what the machine is doing. And of course, that enclosure can be rotated to work on any further sides that are needed. And let's see here. Just need to grab the next video then. And we'll just get a quick look at the laser. So the Perforax laser, at the end of the day, it's performing the same function. Essentially, the Perforax LC, is really designed with the idea of being able to machine stainless steel much faster. So just to give you an idea, it's about a 10-to-1 ratio in terms of speed on the Perforax BC machine, where we're cutting at about 1.2 meters a minute in the XY axes. But on this machine, it's a 1-for-1. Whether we're working in painted carbon steel or in stainless steel, the machine is still cutting at about 1.2 meters a minute. It's not the fastest laser in the world, and that's not the point. I mean, all of the parameters for this machine are really set exactly to not blacken or bubble up the paint, so we're not creating so much heat like you would with other CO2 or larger fiber laser processes. But still, certainly this is much faster than doing anything by hand, and the cut quality and precision is excellent. So just as a demonstration here, Ellie is going to throw in a stainless steel box, and I'll just kind of fast forward a little bit to that position. So that you can see here, the laser is cutting at the same speed as it was with the carbon steel product. And as you'll see, there's no oxidation, browning of the stainless steel. Customers are often very particular about the quality of the cuts and making sure that the surface is not marred. This is a very unique laser in that it can deposit the, or it can pick up, I'm sorry, like a spindle for tapping as well. So we can fully laser drill and then come back and tap out, say, a back panel. So a fully functional Perforax machine, very similar to the last piece we saw. Okay, let me just jump back into the presentation here quickly. Moving on, we also, once we have the data out of EPLAN for all of the cuts and especially the capped and drilled holes in the mounting panel, we then also already have the information required for the DIN rail and wire track, which tends to be responsible for a large proportion of the holes made in a mounting panel. And so the Perforax machine is really a great piece for, it's complementary to that whole process. So, in itself, the machine can be used to optimize the cutting of standard 2 and 3 meter lengths of DIN rail and wire track, and optimize that over several jobs so that we, have the least amount of waste possible. But really where the savings come here is the hand measuring, the walking back and forth to some centralized cutting system on the floor, and piece by piece having to walk back and forth after each cut is made, measuring again and going back to, say, a cutting position on the floor. So I'll just show a very quick I'll finish off here just quickly. There is a machine also that we have for cutting DIN rail, but this piece of equipment, the Atex, actually also will laser scribe terminal block labels, like the little markers or chiclets on terminal blocks, and then assemble those terminal blocks onto the DIN rail. So you're creating an entire terminal block DIN rail assembly with this piece of equipment. And as I said, there are fewer customers out there that really have the volume of terminal block purchasing and use that might really utilize this machine, but we're just showing it to explain that we have a very wide offering to panel builders in terms of automating their processes. So I will just jump back to actually, there was one other video I was going to show you. This is just a very quick video of so the export process out of EPLAN Pro Panel 3D to the Perforax machine. So we're just showing what this looks like. So we select the piece of equipment we want to export to, say OK, and shows that we've got a lot of cutouts and drilled holes to make in this cabinet. So this is actually the interface software for the Perforax machine, and it was exported directly to the database and imported automatically. So we just go down, we find our trade show order here, and when we open that up, we can see the programming for each side of that enclosure. So whether it's the filters, fans on the side, the connectors, the door, the mounting panel, etc. Even right down to the gland plate. So when we go back and we look at the panel in 3D, of course, we can see all of those features on the enclosure itself and where the mounting was taking place on the mounting panel. And I believe at this point I flipped it around, and we'll just turn on the drilling view so you can see that it exactly resembles the drilling pattern that was sent to the machine itself. So, okay. So then, just wanted to move on to a very quick video about the Perforax machine as well. So this is the machine for DIN rail and wire cutting optimization. And of course, like I said before, all the information we need to make these cuts and kit them together was provided to us through EPLAN and through the Perforax software database. So this machine is connected to the Perforax, or can be. Here, we're trying to automate as much as possible the cutting of these materials. So you can see the backstop moves away so that it's easily removable. And so those are safety buttons. That is an open blade there. So we have safety buttons. And then we also produce like a label which talks about the job name, the length of the material, and also the XY position on the mounting panel so that the person doing the assembly does that as quickly as possible. And of course, the same unit can do the cut the DIN rail to length. We have 5 different profiles for different types of DIN rail here. 7.5, 15, and C channel, etc. And then just while we have that that large surface on the top, we decided to use the rest of the area underneath the machine to store tools, documentation, and also stock of DIN rail track covers and DIN rail wire track and covers. Okay. So go ahead and get back to the presentation here. Now, this is really the heart of the discussion that I wanted to talk about, and this is wire processing. So, the one unique thing about designing in 3D is the fact that we now have the opportunity to determine internal wire length, internal conductors inside the control panel. And once we have wire length, then we are able to really take advantage of that information to drive the automation of wire production ahead of time. And so we do have a couple of different routes here. I mean, we do have semi-automated equipment for customers that have lower volumes or certain specific needs for wire cutting, stripping, or strip crimping, for ferrules, whether they're loose piece or they're real fed. But the piece I really want to talk today about, is the automated wire processing solution, the wire terminal. And so this machine, is really going to be driven off of, like I said, the 3D data. And and I'd like to talk about the value of wire length information a little bit here before we take a look at that video. So EPLAN software, as I mentioned, can provide that 3D data, but also just a couple of additional real strong benefits here would be being able to look at thermal dissipation requirements and spacing for climate control requirements inside the panel. So where's the best location for the climate control? Making sure the components are spaced properly so that they can get rid of their heat, and at the same time not interfering with each other or potentially interfering with the door when it's closing. So intelligent wire routing. So we're saying here that we can maintain voltage separation for control voltage versus power voltage, as well as keeping a close eye on duct fill limits. So if we are starting to overfill a duct, we can send it down another route to its destination. And of course, the accurate mounting hole locations for the panels and cutout locations. We've already talked about that, but just to move on here a little bit, and talk about what it actually means to be able to know what the wire length is. So when we were talking at the beginning about the manual process, these are all the steps that we talked about, the reading off of a schematic, stripping, crimping, marking, wire routing, and then doing all of those processes on the other end of the wire. So we've done a lot of time studies, and I've certainly done some myself. If a wireman is able to land a wire every 3 minutes, that person is really moving quickly. So we're using a pretty conservative number here, but often, customers will state that probably it's closer to an average of 5 minutes. But utilizing some of our semi-automated equipment, we can start to reduce that time, significantly. Bringing it down to 85 seconds or even 65 seconds. But if we really go to a fully truly automated solution, like the wire terminal machine, we're bringing that time down to 45 seconds. And that means landing a wire every 45 seconds at the wire station. And let's just take a look at, what we do with that wire. So as you'll see in the video, the wire is actually produced exactly in the sequence that EPLAN told us to produce it in. And that matches up 1-for-1 with EPLAN's solution for shop floor wiring, which is the smart wiring interface. And so this is a tablet or a touchscreen based application, which really very very clearly defines to the person doing the wiring how the panel needs to be wired and wired correctly. So, this has got some pretty strong advantages to it. The person doing the wiring no longer needs to actually, let's say, know how to read schematics, for instance. So that opens up the potential labor pool quite a bit when you're just training people on how to correctly land wires and use these types of electronic interface tools. But really, we're guaranteeing the optimum processing order, during that operation, and just really trying to make the working method as efficient as possible. And so what does that look like? I mean, when we really, of course, that piece of equipment, has a cost to it. So how do we justify buying that as a panel shop? And here's the answer. So very straightforward calculator math. We looked at our 3 minutes and seconds, so the 45 minutes that we, can land that same wire with a pre-processed piece of wire, the delta being 135 seconds. If that panel had 500 wires, that means we've got over 67,000 seconds, and I just showed minutes, and then coming down to almost 19 hours of reduction of time of that panel on the floor. So if we multiply that times a $35 loaded labor rate on the floor, that means $656 per panel. And if a shop is doing, for instance, 500 panels a year, that's coming out to $328,000 that they can put towards, not only the investment of the equipment, but also the software to get here in the first place. So, so that's just a very quick, brief overview. And I realize I'm starting to run out of time, but I would like to, at this point, just show you one last video of the wire terminal machine. This should give you a pretty good idea of the process that we're talking about. So, just in general, we really tried to make this machine as small in terms of footprint as possible. We know that panel shops don't have a lot of floor space out there. Typically, when they're busy, they have none. So we really wanted to try and keep the machine as vertical and small footprint as possible. But here we see, the data coming out of EPLAN that can be sent directly to the machine. And in the back of the machine, you can see there's some wires leading to it. So we can have up to 36 different wire types being fed to the machine. So he's just going to be calling up the order for this particular job at this point, and he's just throwing some labels onto our wire rails where the wires are actually organized in sequence, and then you're able to take those out to the wire stations. In any case, he'll get the machine fired up here in a second. The idea of, like I said, being that we're keeping the wires in a sequence that will then match up on the backside with an interface program like smart wiring. So we are ferrilizing all of the wires, or at least one end of the wire, to hold them in those wire rails that we saw earlier. So we're working with essentially anywhere from 20, to 12 gauge in this process, and as the wire is fed in through that area, the comb up front, we are inkjet printing the wire, so that means the to and from target source information, schematic wire number, etc., directly onto the wire, cutting it to length, and then stripping and crimping the ends automatically. So it's then handed off and then placed, as you see here, into the wire rails. And that's how we're maintaining that sequencing that is going to be very important later. So just wanted to give you a brief overview of what kind of automation we're talking about in terms of wire processing. So it's wire processing has been around for a long time, but having it fit really hand in glove with the engineering and also like a control panel production floor is really the magic here. In that we're making the entire process much more efficient. using other types of wire processing systems may gain some efficiency, but never to that level. And just a couple of words about the Rittal enclosure designs, just so it's understood. That there's if you can imagine looking at the Perforax machine, using very large freestanding 3D welded enclosures can be very cumbersome when loading those onto the machine. Rittal does have a modular design where each of the sides of the freestanding enclosures are removable. So you're handling, say, a 40-pound piece of metal instead of a 600 or 700-pound piece of metal into the machine. All of the Rittal products are available in full 3D in the EPLAN data portal. If you haven't heard about the data portal yet, I encourage you to take a look at that. Let's see. So just the design internally of the panels, even panels like wall mount boxes, are really well thought through, and we're maximizing the available space usage inside of an enclosure. The retherm technology, this is for determining the heat dissipation requirements of a panel, works hand in hand with EPLAN Pro Panel to ensure that customers are not undersizing or oversizing the cooling equipment. Okay, so I am almost done. I'll take 2 more minutes here and just talk about just a benchmark project. I'm sure maybe you've already encountered this in your discussions with EPLAN, but if you haven't, you probably will see this again. We just took a look at a bunch of panel builders out in the world. We wanted to know what they estimated this type of panel would take them to build. And so we have some characteristics here that we're showing of a control panel that we gave them. And they told us that it takes about 58 hours for them to build that panel. And so we looked at the offerings that we have for shop floor automation and determined through some of our semi-automated technology, we can get that number down to about 34 hours. And then using some of our more advanced solutions like we've seen here, we can get that number all the way down to 24 hours. So driving a significant amount of time out of the panel build. And here's kind of what that looks like. So if we think about, the Perforax machine that's responsible for, some of these bars up here, if you were to add them together, they would be pretty much the second largest bar on the chart. But certainly you see the front runner here is wire fabrication and wire installation. So the wiring time essentially that is currently done manually versus how we can impact that through the process of correct engineering in 3D, automated wire processing, and then that smart wiring interface out on the shop floor. So. We do have customers not only in Europe and in Asia, but also right here in the United States that are employing these technologies today. This is here, this is happening. We realize every customer can't bite off on the entire solution, but we do have entry points where you can start having a very beneficial impact on how your company works today and start down that path. I really appreciate your time today. And again, my name is Van Miller. Please feel free to contact me. If you've got questions right now, that's great. If you'd like to contact me or my associates afterwards, please do so. We look forward to talking to you. So thank you again.